Hi everybody, welcome to part 4, in which we talk about inferences for the difference of two means. So we're often not only interested in comparing proportions across two groups, but also averages or means. So we might ask, what is the average income of men versus women in the population? So not based on the sample on hand, but in the population. We might also ask, is the average educational attainment in years in the population different between people who grew up in a wealthy household versus those who did not? In a similar way, we might say, on a scale from 1 to 100, what is the mean level of perceived happiness in citizens of Denmark versus the United States? These are real questions that people have asked. The idea is that we want to compare the mean of two groups, and we want to say something about the population. Right? So this is kind of the comparison we're making. You have a mean of one population and the mean of the other population. And our goal is to make inferences about the difference of these two means. So the point estimate for a difference of two means is simply the difference between the two sample means. That is our point estimate. It's a single number. So the difference of these two sample means, that is a single number. So that's a point estimate. This is our best guess, in absence of additional information, of the difference in population means, the difference between mu1 and mu2. So our goal then is to construct a confidence interval for the difference of these two sample means, to say something about the difference of two population means. So in this example, we will focus on making inferences using the t-distribution because it works for both small and large samples, unlike the standard normal distribution. So a confidence interval for the difference of two means from two independent samples is given by this equation here. So you have a point estimate, so the difference of the two sample means, and then you add and subtract t alpha divided by 2 times the standard error, where the standard error is really it's really this sort of sum in a way. So the idea behind this is that each sample size is given by n1 and n2, and then we use the two different sample variances as estimates for these two unknown population variances. The key point here that we want to emphasize is don't calculate this by hand. We're going to use statistical software to calculate this confidence interval and conduct hypothesis tests. The reason for this is that the value of t alpha divided by 2, it's really a pain to calculate by hand. It's important that you understand substantively, however, what's going on. It's similar to what we've been doing before in the sense that you have a point estimate plus or minus t alpha divided by 2 times the standard error. The standard error is a little bit different, but intuitively, it's really just adding up these two variances and dividing by their respective sample sizes. All right, the next sort of topic has to do with this idea of using computer software. Recall that the t-distribution, it approximates the normal distribution with larger sample sizes, roughly if it's greater than or equal to the size of about 30. All right, most computer programs will use the t-distribution as the default when we're doing statistical inferences involving the mean, including the difference of two means. So the important part here is that when conducting t-tests, we will rely on statistical software rather than calculating these test statistics, critical values, and confidence intervals by hand. So let's go through this process of actually conducting a hypothesis test. A few preliminary steps is that you want to state the target population. So are you examining people in Germany, people in the United States, people in the Ivory Coast? State your target population. And then you want to state the parameters of interest, so the population mean or the population proportion. In this case, we're going to look at the difference of two population means. And then we have several steps. These steps are similar to what we've been talking about before. First step is you want to state the null and alternative hypotheses. The next step is you want to select a significance level, alpha. Right? Typically, we'll use an alpha level of 0.05 by convention. Then you want to compute the test statistic t using statistical software. We will not calculate this by hand. It's really a pain to calculate. And then for step 4, we will assume the null is true. Okay? So we're going to assume that the null is true, and then we're going to make a decision by comparing the test statistic with the critical value or values, and then we're going to compare the p-value with the significance level alpha, and then we're going to state a conclusion. And then, of course, I highly recommend that you actually calculate a confidence interval. So let's go through step one. The null hypothesis for these difference of two means is that these two means are same in the population, so their difference is 0. So for the purpose of this course and the way we're approaching this particular hypothesis test, we're assuming that the difference of these two population means, right? We're assuming that that is 0. So mu1 minus mu2, that's 0. Because in fact, if they're the same or really close to being the same, they're going to be very close to 0. Then, although tests may be right or left-sided, for purposes of this course, we're going to focus on a two-sided alternative hypothesis. This is by far the most common alternative hypothesis test when you're comparing two means. So the alternative for the purpose of this course will be mu1 minus mu2 is not equal to 0. That implies that either mu1 is larger than mu2 or mu2 is larger than mu1. But we're going to really focus on a two-sided test. And in published research and in most articles, almost all articles, this is the most common setup, where you have a null, which is the difference is 0, and then the alternative is two-sided, where the difference is not 0. Then the next step is to select a significance level. So usually researchers will select alpha of 0.05, and this is the criterion for statistical significance. Again, we will use this alpha level to compare it with p-values, determine critical values, and compute confidence intervals. And again, recall that alpha is the probability of a type 1 error or false alarm. Right? Then the next step is you want to compute the test statistic. So the test statistic for two independent samples t-test with a two-sided alternative is simply as follows. So the test statistic is the two sample means, okay, the difference of the two sample means minus 0. Right? That's because the null is 0. And then we divide by the standard error. Again, we're going to use statistical software to calculate this, but you can come up with this yourself. It's relatively straightforward. And we will use the two sample variances estimates for the population variances for these two groups. All right, so we'll use the sample variance of the first group and the sample variance of the second group as estimates for the population variance of the first group and the population variance of the second group. Because recall, these population variances we don't actually observe, so we have to use information from our data as point estimates. Again, we're going to use statistical software, and when we use statistical software, we're going to assume that there are unequal variances. This is typically the more realistic option than assuming that the variances are the same for the two groups. In some statistical software programs, you'll see an option of assuming equal versus unequal variances for these two groups. We're going to assume that they're unequal, that the variance of one group is different from the variance of another group. Again, this is typically a more realistic assumption. You wouldn't always think that the sort of spread of one group would be the same as a spread for another group in the population. Then what we're going to do is we're going to compare this test statistic with a critical value or values. Recall that the critical value or values, it's based on this significance level alpha. Now, since we have a two-sided alternative, right, in which the difference of these two population means is not equal to 0, we're going to use the following critical value for making a decision. We're going to say if the absolute value, right, of that test statistic is greater than equal to t alpha divided by 2, which is derived from the t-distribution, then we're going to reject the null that the difference of two population means equals 0. Again, this t alpha divided by 2, we're going to use statistical software to find that. But intuitively, it's the same as what we've been doing so far. Since we're focusing on a two-sided test, we will calculate the p-value as follows. The p-value will be 2 times the probability of obtaining a test statistic greater than or equal to the one we obtained in absolute value. And we're going to reject the null if the p-value is less than or equal to alpha, where alpha in this case is going to be 0.05 by convention. Again, we're going to use statistical software to obtain these p-values or probability values. Then the next step, using either the critical value approach or the p-value, we're going to make a decision to either reject or fail to reject the null. Recall that the null is that the difference of two population means is 0. If they're the same, then this difference is going to be near 0. Right? So there's really nothing going on. You're going to say these groups really aren't that different. And of course, it is always important never to stop here. Substantively interpret your conclusion. What are you really saying here? And what does this really mean? Right? So then the final sort of step is to conduct a confidence interval. I recommend usually to conduct a confidence interval. The confidence interval we've described earlier. So you have a point estimate plus or minus 2 alpha divided by 2 times the standard error. Right? The standard error is a little bit more complicated, but substantively it's the same. This will give you an upper and lower bound. It will give you an interval estimate, and we're going to use statistical software. Again, we will reject the null that the difference of two population means equals 0 versus the alternative that they are not equal to 0 at the alpha level if the t-interval does not include 0. So again, you can see how statistics builds on itself. The steps we're going through are very similar to what we've covered before with population means and population proportions and difference of population proportions. And with that, we're going to go through a few examples to really explore this idea.